Hello everyone. So today we are going to start our spring lecture series, Lecture 2, and this lecture is regarding lab calculations. So, as we know, work at the bench requires knowledge of several mathematical methods and formula, and they need for scientific notation, measurements of units, and preparing solutions and dilutions, and also some complex statistical analysis. So, as we know, there is a famous quote saying, practice make perfect. After this lecture, we will be able to do some example test, and quiz material can be provided upon request. Everyone is welcome to reach out via comment. So I will be happy to provide over the email quiz material. Uh, Now we'll see what is metric system. Uh, Metric system is predominates in science, and this is important to understand the relationship between terms and how to convert. So mostly we are using weights in grams, milligram, micrograms, nanograms, and picograms. So 1 gram equals to 1,000 of milligram or 10 to the power 3, and 1 gram is also 1 to the power 10 to the power 6 micrograms. And here we can see 1 microgram equals to 0.001 or 10 to the power minus 3 milligrams, or zero point 0.1, and then after 6 decimals, it's gonna be weight of gram. And for volume, we measure in liters, milliliters, and microliters. We have to prepare solution or dilution. So there are different fractions. So for dilutions can be expressed as a solution, uh, 1 to 2, 1 to 10, 1 to 10,000, or can be expressed as a change in strength, 2x, 5x, 10x. So let's say an example, you need to use an antibody at a final dilution of 1 to 5. You need 10 ml of the diluted antibody solution. How much initial sample and diluent should you use? So this is gonna be our question in uh, following slides. So you can note down and then you can try to calculate. Next, two is preparing solution dilutions. How would you prepare a 500 ml solution of 2x TBE buffer from the stock 10x TBE buffer? Okay, so we know in the molecular biology, most common dilution formula is C1V1 equals to C2V2. So where C1 and V1 represent stock concentration and volume respectively, and C2 and V2 represent the diluted concentration that we achieve after dilution and volume respectively. So in this example, determine the volume of 0.75 molar stock sodium chloride solution needed to make 25 milliliter of a working 0.20 molar sodium chloride solution. In example 2, if you have DNA with a concentration of 2 microgram per microliter, how much DNA in microliter must be added to make a 20 microliter solution with a DNA concentration of 100 nanogram per microliter? So here we will implement similar C1V1 C2V2 formula. Another example is percentage by weight by volume. So the formula for weight, percent weight by volume, is mass of solution gram divided by volume of solution milliliter into hundreds. In other words, percentage equals to grams in 100 ml. A 10% sodium chloride solution has 10 gram of sodium chloride dissolved in 100 ml of solution. Example, you want to make 0.5% agarose gel. How much agarose in percentage do you need, grams in do you need to make up a 50 ml solution? So Another example of percentages is by volume, volume by volume. So the formula for weight solution, volume by volume, is volume absolute divided by volume of solution, milliliter into 100. So need to express the percent solute as a decimal. 5% equals to 0.05 divided number by 100. Multiply decimal by total volume, subtract volume of solute from the total volume. Example is, how would you make 500 milliliter of a 8% weight by volume solution of ethylene glycol in water? So now let's talk about molar solutions. So what is molarity? Moles of solute divided by 1 liter of solution. Example, how many grams of sodium chloride are needed to prepare a liter of 1 molar sodium chloride solution? The molecular weight of a sodium chloride is 58.44. So how about making a zero point 0.1 molar solution or a zero point 0.5 molar solution or a 2 molar solution? So we just need to calculate molecular weight according to volume we needed. So sometimes you may need to work backwards to figure out the concentration of substance in a solution. So here is an example. What is the DNA concentration of a 50 microliter solution which contains 10 microliter of DNA at a concentration of 4 microgram per microliter? We have seen some quick examples of making dilutions and solutions. So if you like, you can share your worksheet after calculation and I will review and provide you feedback. And it can be shared by comment or message to share over the email. So I will provide my email if you like to send a comment. And if you have any more question, you can also post and comment. Thank you very much everyone for viewing today's small presentation. And if you have any question, please reach out to me following me on LinkedIn or you following my channel. I wish you guys everyone wonderful weekend. Bye bye now.